Hey everyone, welcome back to the channel. This is Sainath, an AWS community builder. Today, we are diving deep into something really exciting, that is, how to secure your AI agents using guardrails. But before we jump into the demo, let's first understand what AI agents actually are. AI agents are essentially orchestrators. They can plan actions, execute tasks, and even perform reasoning to solve a complex problem. Modern AI agents are incredibly powerful. They can access the database, update the records, call APIs, and even take the decisions. But there's a famous quote and goes as, with great powers comes great responsibilities. And as a developer, it's our responsibility to make our AI agents behave safely. We must ensure that they do not generate invalid outputs, corrupt important data, or execute malicious or unsafe requests. And that's exactly why we need guardrails. We'll learn more about these guardrails shortly. But before that, let's walk you through the AI agent system that we are building in today's session so that we can understand how everything works together. Starting from the left side, we have the user. The user interacts with our system, asking the questions or requesting the actions. For example, the user might ask something like, show me the profile of this customer, or update the customer's profile of this ID. The request is then sent to the customer support agent, that is, this agent, which acts as a central decision maker of the system. The agent's job is to understand the user's request and decide what action needs to be performed. Instead of directly manipulating the data, the agent uses the predefined tools that we provide. In this architecture, we have two main tools. The first tool is Get Customer Profile, which allows the agent to retrieve the customer informations from the data source. And the second tool is Update Customer Profile, which allows the agent to update the customer information. When the agent decides which tool to use, it executes that tools as a task. These tools interacts with our data storage, which in this demo will simply be a JSON file containing the customer profiles. But in actual production setup, these tools will be connected to your data source, the actual data like databases or anywhere your data is present. For example, if the user asks the customer's details, the agent will call the customer profile tool, will fetch the data from this data source and return it back to the agents. If customer asks to modify something, the agent will call the update customer profile tool, which updates the data and saves it back to this file. Now let's look at what happens behind the scene. The agent itself relies on the large language model to understand the user's request and decide which tool to be executed. In this architecture, the LLM is hosted in Amazon Bedrock. So when the agent receives the request, it sends the request to the LLM. The LLM processes the prompts, reasons about the tasks, and determines what actions or tools to be executed. But this is where the important security layer comes into the play. Safeguards, also known as guardrails. Before the LLM output is used or before any action is executed, it passes through this guardrails layer. This safeguard ensures that AI does not generate invalid response or execute unsafe actions. For example, in this demo, we are creating a guardrail to ensure that the AI agent does not provide financial fiduciary advices. The agent is allowed to retrieve and update the customer data, but it is restricted from giving investment recommendations or financial guidance. This ensures the system stays within its intended scope and avoids generating responses that could be risky or legally sensitive. So guardrails are the safety checkpoints. And once the guardrails validates the output, the agent can proceed to execute the required tasks or return the final response back to the user. So final flow looks like this. The user sends request to the agent. Agent interrupts it using the LLMs. Guardrails validate the output. Appropriate tools is executed. The data is retrieved or updated and final response is returned back to the user. This architecture ensures that our AI agent is not only powerful but also safe, controlled, and production ready. Now, now before we actually build this system and see how guardrails prevent the unsafe actions, Let's first understand what guardrails really are and why they are important. When we talk about the AI agents, we are no longer talking about the simple chatbots that just answers the questions. The modern AI agents can actually take the actions. They can call APIs, they can access the database, they can update the customer records, send emails, or even take the financial decisions. And that's incredibly powerful, right? But the moment an AI system is allowed to interact with the real systems and the real data, an important question appears: how do we make sure AI behaves safely? And that's exactly where the guardrails comes in. Guardrails are essentially a safety mechanism for AI systems. They define the rules, validations, and constraints that control what AI agent is allowed to do and what it is not allowed to do. You can think of guardrails like the railing on the mountain roads. When you are driving through the dangerous mountain paths, those railings don't stop you from moving forward. They simply prevent you from falling from the steep. In the same way, guardrails don't stop AI from being useful, but they prevent you from making dangerous, invalid, and harmful decisions. Now, you might ask, why is this actually necessary? Because large language models, LLMs, are probabilistic systems. They generate the responses based on the patterns in data rather than the strict deterministic rules like traditional softwares. This means sometimes they can produce outputs that are incorrect, unsafe, and unaccepted. For example, imagine we have an AI agent that manages the customer profile data. If we ask the agent to update the customer profile data, that AI agent might attempt something like to modify some other informations or the informations that was never meant to be modified. Without guardrails, that AI agent might execute this action simply because the prompts or the responses generated by the LLM suggested it so. And another important reason why guardrails matter is security. AI systems are vulnerable to the prompt injections, where users might attempt to manipulate the model into performing actions and try to get their actions done. Guardrails help us to detect this and block these malicious inputs before they reaches the critical system. So, in simple terms, guardrails provides three major benefits. First, they protect data integrity, ensuring AI does not corrupt or modify data incorrectly. Second, they improve reliability, making AI systems more predictable and production ready. Third, they increase security by preventing malicious and unsafe activities. As AI agents are becoming more integrated in real world applications like finance, healthcare, and enterprise system, guardrails are no longer optional. They are the critical layer of security. So in this video, we are going to build a simple AI agent that works with customer data. First, we'll see how our agent behaves without any guardrails. And then we'll add the guardrails step by step to ensure that the agent performs only safe and valid operations. So now let's get into the hands-on session. So open your favorite editor, and then in here firstly we will create our virtual environment, and then we got that pnb, and then we'll create a requirements.txt file, and here we will install these libraries, that is boto 3 strands agent tool. So we will install these libraries, and then firstly we will create the logic to implement the dummy data, that is this data, this, so that our tools can interact with this. So we will create that tool first. So let's first install the requirements text file. Yeah, we have installed the requirements file. And then in customer profile we'll write our logic that. So firstly we'll import JSON, and then this is the function, and don't worry, the code will be provided in my GitHub repository, and the link of that GitHub repository will be in the description. You can check this code. So firstly we are creating a simple file, a simple function that is generate customer profile, and this customer profile will return this customers. There's a user ID of the customer, there is a name of the customer, age, country, and then financial profile like monthly income, monthly expenses, saving, emergency fund months, and debt. And then next we have this another function that is save customer profile. So when the this file will run, this function will be called, and in this function in return calls the our generate customer profiles function, and we'll get all the profiles here. And then here we are creating a JSON file named this customer dot JSON, and in that file all the customer data will be written. And now these other functions are used by our tools. For example, this, and now this is a private function, this can't be directly used, but it can be called from other function. So here we have a function called get customer data, and this function will be used by our first tool, that is get customer profile data. And here you can see we are passing a customer ID, because to get a customer data we need a customer ID, and then path of the file. We have this default field here, and here it will search that customer profile data with that customer ID in that JSON file, and it will filter out and it will send that customer data here. If it don't have, it will send the return as none. And then we have the other function that is used to update the customer data, and again customer data is updated via the customer ID only, and will also send what fields need to be updated, and then the default field is JSON file. This function will be used by our second tool, that is update customer profile. And now this is our main function. So we are calling this save customer profile, that is this. This will create a JSON file and will save. So let's have that. Let's run that. And there we go. So we have this customer profile.json file created. Here it is. So now let's test these two functions, because we need to test these functions because these functions are two used by our tool. So let's first test these functions and see whether they are working according to our need. So, so here what I'm doing is I'm importing the customer data from this file, customer profiles. So here it is, customer, think from customer profile import customer data and update customer data. These two functions we are importing, that is this and this. And now here let's first test. So we are calling the get customer data with this ID. And is there any ID? Yeah, we have this ID. And now let's test that. And yes, we are getting the data back. And this data will be sent to our agents. And now let's test the other, that is to update. And here you can see that in this function we are updating depth as 0. Let's first check. We have as 0. Let's take a new one. Here we'll take this ID, and we will change update their depth to 0. Let's test that, and here you can see that it is updated. And yes, our both functions are working according to our needs. Now it's time to create our tools. So now let's create our function agent tools.py, and here let's first import all the required things, that is our functions, that is these two functions that we just created, and then we are importing tool from the strands and the dictionary from typing. And next, this is our tool to get the customer profile data, and here you can see we have added this at the rate tool, and now this is a decorator. Why we add this? Because we write a function, and to make this function a tool we add this decorator. So simple. And then here you can see we are passing this function customer id that will be given by our llm, and then we are returning a dictionary, and here is a doc string. You can read this: get customer data by customer id, and the arguments we are passing is customer id, that is a string, and that is required a unique id associated with each customer for lookup, and then returns a dictionary customer profile information or an error message if there is a no customer data associated with that id. So here we are checking if not customer id means if user do not send any customer id, he will straightly get this error. And then and then we are creating a profile variable here, and then we are fetching that, calling that function, that is get customer data, and passing that customer id here, and we will get that profile. And if we do not get any profile, we return customer profile not found, and then if you get that profile, we'll simply return that profile. So this is a simple tool. Here we have. And then next we have this another tool, that is update customer data, and here you can see uh, we are passing two things to this tool, that is customer data and updates, and this is also a dictionary, and in return it is returning a dictionary. You can see the read this doc string: update customer profile information, arguments we are passing two things, that is customer id, that is a string, and it is required, and another is updates, which is a dictionary and required dictionary of fields to update with a new value. You can see this. In this dictionary we will get the fields that needs to be updated of the user profile, and in return we will return the final profile here. And here again we are checking if the customer data id is not given, you will get this error. If no updates, he will still get the error. And then printer issued customer id, this is just for debugging purpose. Let's remove this. This is also for debugging purpose. And then here we are creating a profile variable and calling that update customer data function and passing two things to it, that is customer id and updates. And if we get the profile, we'll simply return that, or if we don't get, we will return an error saying customer profile not found. So simple. We have two tools created now, and now it's time to create our agent and add these two tools to our agent. Now let's create that agent file, agents.py, and here firstly we will import all the required things. So here we are importing os, we are importing agent from tools, us from strands, and then we are also importing bedrock model. So to create our ai agent we need a model, and we need to create that model via this bedrock model library. So we are importing this bedrock model, and we'll pass a model to this bedrock. And here I am also importing two functions that we created. sorry, two tools that we just created from this agent tools file here, and they are get customer profile and update customer data. And next we are creating this bedrock model, and here you can see I have passed the model id, and the model we are using is sonnet 4, and here you can see we are using inference profile model. And next we will pass this bedrock model to our agent, and here it is. So let me word wrap this. So here it is. We created an agent, and this is so simple to create an agent. We just need to create a agent function, agent method kinda, and pass our bedrock model here and a system prompt. And here you can read the system prompt. You are a helpful assistant that provides your profile informations and a financial advisor that can update your financial profile based on input. You have access to the following tools to get and update the customer information. And the tools are this customer get customer profile and update customer data. And now let's test this agent. And as I told, firstly we will test this agent without guardrails and see how this agent is misbehaving. And as I earlier told, we are creating an agent that is restricted to provide financial fiduciary advisors or any financial recommendations. Now let's test our agent. So we'll call our agent here, and here we'll pass our prompt. And I have already created some prompts here. So these are prompts that we will test, and then we will print our answer here. So firstly, this is our prompt, and then I'll simply call our function, sorry, our agent. And the prompt is just asking who you are and how can you help me. And here we get the response: hello, I'm your personal financial assistant and advisor. Here it is telling us what I can do: retrieve your profile information, update your profile. How can I help you? It is asking us questions: how can I help you? And yeah, we are getting the cool response from our agent. And now let's give a prompt to our agent so that it can use any one of the tool. So this is our second prompt that we will test. And here I am simply telling that this is my ID. I am telling you to summarize my profile. And we are calling our agent. And now it has triggered our get customer profile tool. And it has summarized also. This shows an excellent discipline and planning adjustment. And yeah, it has summarized my profile now. Cool, right? This is how our agent calls the tool. And now how this agent get to know that it needs to call that tool? Because of our llm. Our llm said that we need to call a tool, and our llm know that it has an access of our tool, and internally it called our tool, that is get customer profile. And the tool sent the response to again back to the llm, and then llm did the reasoning part on that context. And now let's test our other tool now. Simple other tool. We are telling to change my monthly income to something and expense to something. Let's test that. And there we go. It has now updated our income, and it is saying that it has updated. Let's check that back here. And here it is. Income is updated and expenses is also updated. Yeah, it's cool. And now let's see how our agent misbehaves. As I earlier told that we don't want our agent to answer the queries where the user asks to give financial advices or recommend any financial profiles, kind of stocks or mutual funds, something like that, right? So let's put that query here and see our agent responses. And our requirement is that we don't want our agent to respond such queries. But now without guardrails, let's see what happens. Called firstly it has called the tool and retrieved my profile, and then here it has created investment recommendations. Here it is giving some recommending some mutual funds, large cap, mid cap, index funds, Motilal Oswal, and some stocks. Yeah, now it's kind of recommending me some kind of stocks, mutual funds, and other financial assets, right? But technically, we don't want our agent to recommend such things, because we don't want users to blindly follow whatever our agents says. So we don't want our agent to use such responses. And now we will look into how guardrails comes into this picture and restricts the users to query such questions, and we'll get the response that the agent is not able to provide such queries where the user is asking about financial informations, financial assets, and kind of similar. So now let's look into the guardrails part. Now let's actually create our guardrail. So first let's create a file, guardrails.py, and here we'll paste the entire code that will be creating the guardrails. And don't worry, I'll be explaining this file. So in this code, we are defining the guardrail that prevents our AI agent from giving financial fiduciary advices. And firstly, we are importing Boto 3. So Boto 3 is a library which is a AWS SDK for Python. This allows us to interact with AWS services directly from our Python code. And next, we are creating two clients, Bedrock client and Bedrock runtime. First client is Bedrock. First client is Bedrock client, which is used to interact with the Bedrock services itself, such as creating guardrails or managing other models or accessing any Bedrock services. And next is we are creating Bedrock runtime, which is used to actually run or invoke the models. And next, here we are using Bedrock client to create our guardrails. So we are calling create guardrail method here, and inside that we are writing all the required things like what guardrail is, what policy it should follow, and everything like that. First, we give the name to our guardrail, that is no investment advice, and next a brief description, this one, so that we can easily know what this guardrail is. Topic policy config. Topic policy config allow us to block a entire category of context, like any specific category that you want to block entirely. And here we are creating an array, and in this array we can pass multiple such categories. So we are passing the fiduciary advisors and defining what does that mean here. So let me first word wrap this, and here you can read this, what does this fiduciary advice mean. And we also include some examples here. These examples helps guardrails to understand the type of content that we should be restricting, not we, guardrails should be restricting. And you can read some of the examples, and you can provide at most five such examples. And then next we have given the type as deny, and then next we have these two fields, input enabled and output enabled. So by output enabled, guardrail will also check in when our model generates some responses, and our if model generates the responses that is related to these topics, then our guardrails will block that response. And next we have the content policy config. This configuration protects the system from unsafe and harmful content, And here we apply the filters for several categories such as sexual, violence, hate speech, insult, misconduct, and also prompt attack. And here you can see that all here, and we have also given the input strength and output strength. And now what does that mean? Our guardrails should act aggressively on input and output both. And then next we have word policy config. This allow us to block the specific words or phrase that, example, if user is querying something and if that query has such words in that query, then the guardrails will block that query. Or if the model is generating any response and that response has any such words, then still that response will be blocked by our guardrail. And then next we have this managed word list config, and the type as profanity means AWS itself will take care to look into some extra things, like if user is querying some abusive words or vulgar words in such things, the AWS itself will flag that queries so that we can easily trace such queries. And then next we have this two queries, that is blocked input messaging and blocked output messaging. What does this means if user is querying something and his query itself got blocked by our guardrail, then he will get this response. And then output messaging means if user queried our model and our model generated some response, and then that response is such a that our guardrail is blocking that response, and then user should get some response back. So this is that response that user will get. So this is when the input is blocked and this is when output is blocked. And then finally here we are printing guardrail ID and guardrail ARN. So now let's run this. So guardrails.py, and there we go. Our guardrail is now created and this is the ID and this is the ARN. And then now it's finally time to test our guardrails. So firstly we'll take this both ARN and ID, copy this and go to your agent here, and here we need to pass that guardrail and guardrail ID here. So firstly we will take them here, and then we will create two variables, and then we will take that ID here, and then guardrail version, and then guardrail version as draft, and then we need to pass that both here. Guardrail ID as guardrail ID, guardrail version as guardrail version. And now yes, we have passed both the required things here. So we need to add a comma here. And now let's test this once again. So again we are passing the same query here. Now let's see whether it will block our response or not. So we are running Python agent dot, but before that, here I need to add one more comma. I was getting that error. Agent.py and simply hit enter. And there we go. And here I got the responses. I apologize, but I am not able to provide a fiduciary advices for your privacy and security. Please modify your input and try again without including financial and restricted details. And that's how the guardrails come into picture. You have seen we asked the query that was triggering our guardrail, and see how our guardrail was triggered. We asked a query that was meant to give financial advice or financial recommendations. But as we added the guardrails, our guardrails will block that and send us the response saying that it is not able to generate because we have guardrails applied. Now that we have tested the guardrails, we can clearly see how they help us to control the behavior of our AI agents. Then we asked When we asked the normal questions related to the customer profiles, the agent worked exactly as accepted. It was able to retrieve the customer data, it was able to update the customer profiles. But when we tried to ask the questions related to investments or any financial advisors, the guardrails immediately blocked the response. Instead of generating unsafe or restricted content, the system returned the predefined output block message. Let's quickly recap what we have built in this video. Firstly, we created a simple JSON file that stores the user data. Then we built our customer support agent that is capable of interacting with our two custom tools, that is get customer profile data and update customer profile data. Next, we integrated our Amazon Bedrock with large language models that provides the reasoning and decision of the agent, that is this LLM. After that, we created our custom guardrails that prevents the model from providing financial advices and also applies the additional safety filters like harmful content protection and prompt attack detections. And finally, we connected the guardrails to our agent and tested to ensure that the requests are automatically blocked. And as you saw in the demo, Guardrail successfully ensured that our AI agent stays within its intended scope and behaves safely. This is extremely important when building production grade AI systems, especially when they interact with your sensitive data or critical business operations. Guardrail helps developers build AI applications that not only powerful but also secure, reliable, and production ready. So to clean up your workspace, come to your AWS console and go to Amazon Bedrock. And here you scroll down in this left menu, and here you will find guardrails. Here it is. And here you can find the guardrail that you just created. So simply select this guardrail and delete this guardrails. And yes, now your guardrail is successfully deleted. And now, if you guys enjoyed this video and learned something new about securing AI agents with guardrails, make sure to like this video and subscribe to my channel for more such content on AI and cloud. Thanks for watching this video, and I will meet you in some other video. Till then, bye bye.